Hei. Kau tu?
Mana boleh, you kecil lagi.
Hei.
Tengok.
Tengok sikit. Oh, ada Najib tu.
Mana Najib?
Tu. Dah pas tadi.
You ada Insta tak? Ada Insta tak?
Ada, nanti kau add.
Boleh.
Okey. HAZIQ. Apa kamu tengok?
Tak, gambar aku kawan hantar ni.
Gambar buruk tu.
Tak tahu aku gambar apa ni.
Comel tu.
Teruk betul lawan ni.
Lah.
Dia kenal tak? Tak kenal kot. Aku nak jumpa dia first day.
Tak apa. Reminder, please submit engineering mathematics assignment on 5 PM tomorrow. Lambat, tolak 20 markah. Hei. Apa assignment tu? Ada ke soalan kat mana? Soalan kat mana lah? Jom check Facebook.
Cek.
Ada?
Tanya grup.
Tanya kat grup. Ada lah. Doktor dah upload kamu 12. 6 soalan lah. Esok kena hantar. Mana?
Jom lah.
Oi, cepat Zik.
Weh, sabar jap.
Cepat.
Alamak.
Nanti tak sempat.
Weh, sempat.
Tolak 20 markah.
Pelik 20 markah.
Tak 20 markah.
20 markah tu penting, nanti tak dapat masuk final.
Aduh, tak apa, kita boleh repeat mah.
Okay, kita berapa soalan kan? Assignment?
Kita 6 soalan lah.
Weh, 6 soalan lah.
Banyak lah. Kamu ingat 2. Kalau 2 saya boleh buat seorang.
Okay.
Macam ni kita
So,
buat
seorang 2 lah.
Okay, boleh.
Kan?
Seorang 2. Aku cok yang soalan 1. Aku cok soalan 1.
Lepas tu aku ambil 2.
Sure. So aku 3 ni ya.
Yes.
3. Bob ambil 3 Bob.
Siapa lambat?
4 siapa nak?
Aku lambat.
4. Aku ambil 5 lah.
Oh, seriously aku 6 juga.
Kamu 6 lah.
Kau yang paling susah.
Okey.
Sebab kau pandai Bob.
Terima kasih macam ni member
Memang lah member baik ni. Zik cepat. Kenapa bawa 20?
Ni dah cukup laju ni.
Laju.
Ni paling laju ah.
Laju.
Ni paling laju.
Sini Mi Valley tau. Sampai kalau 20 ni sampai KTM pukul berapa?
Biar lambat selamat.
Sekarang dah pukul 12 lah.
Relax
Tak apa, relax je. Kita boleh buat match kot.
Match je kot. So korang memang semua skor A lah. Cepat sikit bagi 40.
Okey, 40
Okey. Lagi 60.
Oi, itu paling laju kot.
Ada polis depan oi.
Lagi sebab. Sangkup pula. Okey.
Jangan accident pula kat sini.
Tak.
Tengok laju betul kamu bawa.
Oi, ini paling laju.
Potong banyak ni.
Potong semua kereta kan.
Potong bagi TV. Pressure lah. Ekspor ni. Cepat. Max tu. Macam mana ni? Tak tahu apa. Nak sampai KTM. Kita tu juga. Ini. Tunjuk je 30. Yang 105.
Parking cepat. Oi.
Sabar.
Tak sempat ni.
Sempatnya.
Okey.
Oi, cepat. Jom.
Biar aku explain soalan nombor 1. Okay. This function. So first we need to simplify the function into a simpler form. Okay. This is how we simplify the function. First we need to change the function into this division. Okay, this is the simpler form. Then the next question is when ns equal to 10s, and the question asks us to simplify gs over 1 plus gs and s, where ns equal to 10s. Based on this function, we need to do like this. We need to put the simplify function into the gs. So we get this. Okay. Then we need to multiply the numerator and denominator by 4s plus 7, or known as we conjugate the function. Okay. After we conjugate the function, we get this s squared plus 5s plus 2 over 14s plus 7 plus 10s, which is ns, multiplied by s2 plus 5s plus 2. Then we need to solve the function by simple maths. Okay, this is the final answer. Okay, that's all. Oi, Sheng, you tidur ah? Ni aku explain ni kau rasa tak dengar? Ni cepat soalan nombor 2 kau kena explain ni.
Okay,
aku dah explain soalan nombor 1.
Okay, aku explain nombor 2.
Okay.
Bangun. Kamu dah kejutkan aku. Aku terang je lah nombor 2 yang aku buat. Okay, tengok sini. Okay, so the question given is the power P dissipated by R1, R2 and R3 is given by P equal to I1 square R1 square R2 plus I minus I1 square R3. Ayah. Dia tak beli ori. Okay, so show that the P is minimum at this equation, means I1 equal to R3 over I1 plus R2 plus R3.
Okay.
So this is the answer, this is the solution. So this is the original formula given. So we derive it, we simplify it until we get this I1 square R1 plus R2 plus R3 plus I square R3 minus 2I1 I R3.
Okay.
So we need to show that the minimum power at that equation, show that P is minimum at here. So we need to differentiate it. So we get this answer: 2I1 bracket R1 plus R2 plus R3 minus 2I R3. So at minimum power dP di equal to 0. So this equation is equal to 0. So R1 plus R2 plus R3 equal to I3. So I1 equal to this equation, means the equation given as above. And we do double integration and we get this 2R1 plus R2 plus R3, which is greater than 0, means dP di is minimum. R is equivalent resistance of R1, R2 and R3. So we have to show it, show that the equation is correct. So we look at the answer. So when P is minimum, I1 equal to R3 over R1 plus R2 plus R3I. V equal to IR equal to R3 over R1 plus R2 plus R3I and R1 plus R2. So R equal to R3, R1 plus R2 over R1 plus R2 plus R3. So this show the equation given as above. Okay. Hey Bob. Hey Bob, dah sampai kamu ah? Bila kamu nak buat ni soalan 3? Saya dah siap ni soalan 2. Aku sambung tidur ah, kamu buat cepat. Hey, dah 1 jam ni. Bangun.
Okay, so I will explain question number 3. As you can see, this is the formula, which is an AC current. So we have to find the amplitude and sketch one complete cycle for omega to 1 pi. Okay, so for my first step, I use Microsoft Excel for my simulation tool. So for first thing we do is fill in the information for T 100 pi T, 3 cos 100 pi T, 4 sin 100 pi T, and lastly is the full formula. I equals to 3 cos 100 pi T plus 4 sin 100 pi T. So for the next is Okay, so for the column of t, we insert the numbers from 0.000 until 0.020 to get a much more beautiful graph later. So after I've inserted the value of t, we can now proceed to the other calculations, such as the 100 pi t. This is the result of the other calculations, as you can see from here. And so we move on. Okay, after we have done all the calculation, we draw the graph. It will look similarly to this. So for the amplitude, the highest is reached 5, but from the table it is 4.999, so we can assume it is 5. And that is my final answer. Do you get it, HAZIQ? Oi, HAZIQ.
Apa
Boleh lah kau tidur, oi bangun.
penat lah, susah tu Max. Weh Bob, kau tengok soalan nombor 4 ni. Susah soalan ni.
Ni tengah main COC ni.
Weh, tak boleh COC tak penting. Ni lagi penting ni. Soalan application susah ni.
Okay, faham. Okay, cepat tunjuk.
Okay, soalan nombor 4 In an underwater telephone cable, the ratio of the radius of the core to the thickness of the protective sheath is denoted by x. The speed v at which a signal is transmitted is proportional to x squared ln 1 over x. So the question is, show that dv over dx equal to kx 2 ln 1 over x minus 1, where k is some constant, and hence deduce the stationary values of v, distinguish between these stationary values, and show that the speed is greatest when x equal to 1 over square root of e exponential. Okay, so this is the solution, Bob.
Yes.
If v is proportional to x squared ln 1 over x, that means v equal to kx squared ln 1 over x, where k is constant. Okay?
Okay.
Differentiating v with the respect to x, we have d over dx v equal to k, which is a constant, ln 1 over x, d over dx x squared plus x squared, d over dx ln 1 over x, which is we put as equation 1. And now d over dx x squared equal to 2x is equation 2. And because ln 1 over x equal to ln x to the power minus negative 1 equal to negative ln x, we have d over dx ln 1 over x equal to negative d over dx ln 1 over x equal to negative 1 over x, which is the equation number 3, the third equation. Okay, so we put the second equation and the third equation back into the one to get d over dx v equal to k 2 ln 1 over x minus x squared 1 over x, or d over dx v equal to kx 2 ln 1 over x minus 1. V is the turning point when d over dx equal to 0, so set kx 2 ln 1 over x minus 1 over 0. We set dv over dx equal to 0 because that's the turning point of a curve. There are two possibilities, x equal to 0 and 2 ln 1 over x minus 1 equal to 0, or ln 1 over x equal to half, or 1 over x equal to exponential to the power of half equal to exponential equal to the square root of exponential, or x equal to 1 over square root of exponential. To find which is at the maximum, we differentiate the equation again. This d squared over dx squared v equal to k. Okay, this is the equation. After we differentiate again, this is the answer. When x equal to 0, this is the positive infinity. When x equal to 1 over square root exponential, this is 2 ln exponential half.
minus 3 equal to negative 2. That is, it is negative. When the second derivative is negative, the function is maximum. Hence, the maximum occurs when x equal to 1 over square root of exponential. Okay. Tu je Bob.
Haziq.
Ya.
Ni mesti dengar ni, penting juga.
Aduh, soalan apa ni?
Bob. Bangun.
Okay.
Dengar ni penting juga.
Jom Bob. Aduh,
mari.
Teruskan.
Okay, ikutlah. Okay, so this is the question given. X equal to 0.96, 0.97, 0.98 until is given x equal to 1.04. So this is the fx they given, 2.5 until 2.9 something. Okay, and this data can be represented by fx equal to x exponential to the power of x. So they ask find exactly f prime 1. So this is the solution.
Mana?
Here. Bob.
Ya.
Ikut tak?
Okay, saya ikut, saya follow.
Okay. Bye. Okay. So this is the equation given. So we let u equal to x. So du dx equal to 1. V equal to e x. So dv dx equal to exponential to the power of x. So we can calculate it f prime x by using, what rule is this Haziq?
Ni macam product rule je ni.
Yeah, this product rule.
Oh,
I thought you don't know.
Tak perasan ni.
Okay.
Pandai Haziq.
So we substitute all this which we calculated, and we get that f prime equal to x ex plus ex. So f prime 1 equal to 1 e1 plus e1. So the final answer we get is 5.43656. Okay, so the next question given is use central difference approximation to find f prime 1 for various of h, and then we use the same h to find f prime 1 using forward difference approximation. So f prime, this is the equation for central difference approximation. So what we get is when h equal to 0.01, our error is negative 0.00344. When h equal to 0.02, our error is negative 0.00094. When h equal to negative 0.03, error is negative 0.00177. When h equal to 0.04, our error is negative 0.00344, which is same with the h equal to 0.01. Okay, next you can see this 0.01, the error is same with the h equal to 0.04. So next we're using the forward difference approximation. This is the formula. Okay, this OH is the error. Okay, let's start to calculate it. When h equal to 0.01, error is negative 0.4344, then negative 0.04344. So okay, when h equal to negative 0.02, error is negative 0.08344. When h equal to 0.03, error is negative 0.12344. When h equal to 0.04, error is 0.16594. So we can see this when 0.01 is 0.04344, and the error is increasing. Can you see this?
Okay, nampak.
So what we can see this is when we using central difference approximation, the value is very uncertain. It can become more and less, more and less. But when we use this forward difference approximation, okay, let's see here. The value is increasing, as you can see. Negative 0, negative 0.04, negative 0.08 means the error is increasing. Okay. Hey Bob.
Oh, okay, sorry.
Okay, soalan kamu.
Ya.
Mari.
Soalan last ni Bob. Come on Bob.
Okay. Jom. Semangat.
Okay, dah pukul 3 ni. Cepat. Aku nak tidur lah.
Aduh, dah lambat ni nak edit lagi.
Okay, sorry. Okay, dah baik. Sorry. Ni okay, I will explain the last question is number 6. Ni Zik, dengar baik tau.
Okay.
Ni, Sheng, kau sama tak?
Okay.
Nanti duduk. Aku tadi dengar kau banyak explain lama-lama.
Okay.
Saja je nak bagi kau faham.
So for number 6 is about function. We have two functions, fx equals to 1 and fx equals to negative 1. So all I have to do is catch its graph and obtain a graph of another function which is gx for negative 4 less than equal to x, and which is negative x is more than equal to negative 4 or less than equals to 4. So for the first graph is the function 2 of the fx. We first use again Microsoft Excel. So for the first column we put x and then fx. The range is 0.5. You can see that from 0 to 0.5 and 0 to negative 0.5. So after I have put all of the information, we will get this type of graph. You can see this is the graph. And moving on to the next step, which is to find the graph of the gx function. Firstly, we must integrate first. You can see we will have two answers, which is x and then the negative x. So moving on, the range is also the same, 0.5. So again, I use Microsoft Excel. The first row is x and then another one is dx. So after I have put all of the information, the graph will look like this.
Ui, garang ah.
Okay, so we have done most of parts of the questions, and then lastly we have to show that gx is a predict function of 1. To show that gx is a predict function of 1, we use a property of function which is gx equals to gx plus l. L is the period. This property will only work if the gx function is periodic. Since we want to show that gx is periodic, we will use this property. Okay. From the question, we know that period of the fx function is 1 and fx is the periodic. We will use it into this formula. So we will start with this equation, which is gx plus l equals to gx. So gx plus l is equals to this, equals to x plus l 0 ft dt. Okay, so we will need to expand this equation. We will use this property where this is the x plus l, this is 0. We will change it into plus to another two equation, b plus b and c and a. So it will be like this: x plus l and l and 0. So to move on, since we know that from the equation in the question, gx equal to l0 ft dt, so this will be gl. So we just change the x to l. And then for our next move, we will know that from the assumption from above. I will show that GL is equal to 0. We can now put GL is equal to 0. So and then we must use another type of properties where we need to remove the x plus L in this equation. So we will use this equation. Since this we minus with L and this is also minus with L, and here we need to plus L in order to balance the equation. And so after minus with the L, we will get this. Since Ft plus L is equal to Ft, we can change Ft plus L into this, and so thus this is equal to Gx as the mentioned in the equation above. Give me a second. Tak apa, Bob. Like this. So in the end we have proof that Gx is periodic. That is the end of the question. Thank you.
Wah, Bob, gila lah. Oi, Sheng, dah habis ni?
Okay, jom balik tidur, jom.
Oi, dah pukul berapa lah?
Oi, pukul 4 dah.
Serius lah, pukul 4?
Yelah, tengok dia explain lama lah.
Oi, biasalah Bob lah.
Korang buat explain lama.
Oi, mana dia?
Explain sekejap ni.
Jom balik tidur.
Okay, jom. Kemas.
Okay.